Hello everyone, welcome back to STR8CHEM. In this video, we're going to look at the relative atomic mass, or often abbreviated as RAM. Also, you would be able to see this written as the AR symbol. So if you see this, the one in purple or the one in red, that means those symbols refer to the relative atomic mass. Now, what is the difference between relative atomic mass and the average atomic mass, of which you have seen in the previous videos in the asynchronous learning package? To understand this, I think it's better for us to look at the example right away. For example, over here, we have bromine, and the average atomic mass, again, average atomic mass is 79.904 with the units AMU. Again, this is the average atomic mass. So what about the relative atomic mass for bromine? Is it going to be the same? Is it going to be totally different? Okay, remember, we are comparing average atomic mass and relative atomic mass in this section of the video. So let's have a look. So the relative atomic mass of bromine will be the same number or magnitude, 79.904. But the difference over here is on the existence or the absence of units. In the average atomic mass, as what we have learned before, you must include the units, AMU. But when the question wants you to find the relative atomic mass, you mustn't include the units, just like this. Let's have a look at another example, shall we? Right here, we have the average atomic mass for copper, which is 63.54 AMU. So what is the relative atomic mass for copper? Yes, it will have the same magnitude, but it doesn't have a unit, okay? AMU units exists for the average atomic mass, but for the relative atomic mass, you do not have to write the units. Now, some people might gonna say, if relative atomic mass has no units, dimensionless, how can we prove that mathematically? Can we do that mathematically? Yes, we can. Let's have a look at this. Now, the relative atomic mass, or abbreviated as AR or RAM, is defined as the one atomic mass units is a mass unit equals to 1/12 or 12th the mass of a carbon-12 atom with the mass of 12.000. This is the mass of carbon-12. So you have the word relative. Relative means you want to compare the average mass of the element with 1/12 times with the mass of carbon-12. Some of you might be asking, why do we must use carbon-12? Can we not use something else? Before the scientists, before all of the chemists, they came together to have a unified understanding on this, we do have a different way to relate or to produce a relative atomic mass, but that is not in your syllabus. So this is the basic. So this is the only basic on how you need to know how to change average atomic mass into relative atomic mass. Again, I repeat, relative atomic mass has no units, and that can be proven through this formula over here. Let's take bromine again. Bromine has the average atomic mass 79.904 AMU. So you want to change this into relative atomic mass by using mathematical equation, mathematical approach. So what you're going to do over here is you're going to take the average atomic mass of bromine. Okay, so you're going to substitute on top over here. Thus, you have this 79.904 AMU over 1 over 12, 1 over 12 times the mass of carbon-12 AMU. The one in red over here will remain constant. You don't have to worry about that, okay? So when you look at this, you will see that when you have 1 over 12 times 12, you will have 1. But the impact of doing this is when you have the units to cancel out one another. And that is the reason why the relative atomic mass, they do not have units. So in exams, this step over here will give you 2 marks. You have 1 mark for this step, and you will have 1 mark for your relative atomic mass written down correctly. Let's have a look at another example. So this is the example of a calculation when the question wants you to find out the relative atomic mass, and the question gives you the isotopic abundance and isotopic masses. The one that you are looking at now is similar to what you have done in the basic problem solving and also hot problem solving. So right here, you can see that you are using the Ikimiki formula approach. You substitute all the value over here, and then you will find the average atomic mass 55.85 with the unit U. Remember, the units for average atomic mass, you can use AMU or you can use U. Still the units. Okay, so for doing this, of course, you're going to have 1 mark for the substitution, 1 mark for the correct final answer. But if the question wants you to find relative atomic mass, you have to add additional steps. You have to have this step over here. You take the average atomic mass, and automatically you will have 1 mark over here, and you have 1 mark over there. This you don't have to ignore. You have to ignore that one. Okay, so this is the way you're going to be converting average atomic mass into relative atomic mass.